Okay, we'll go ahead and get started. It's 5 past, or a little after 5 past, so this way we can get everything. May have a little few minutes off at the end. Again, this is 11.5. Today, primarily, I'm going to cover a lot of formulas, reinforce all the formulas, and in fact, right now, I want to go through and we'll hit all of them. I've said over and over, you've got to make sure you've memorized these formulas. If you have the formulas memorized, you understand what's going on, everything's a piece of cake. If you don't know the formulas, this chapter is going to be hard, as well as the next two chapters, which are going to be based off of this chapter. So don't try to memorize them and say, wait 5 minutes before you take the test, memorize them, hurry up, take the test, and then forget them. Can't do that. And as you've seen in a lot of problems so far, I've been already hitting and reviewing a lot from the whole semester. So again, going back to some of the basic formulas, and then we'll get into this. Area was the key one, and if I say the area of a square, try to help you get them in one place, that is the side squared. Side squared. And we stepped that up a little bit and said the rectangle or a parallelogram, which effectively are the same thing as far as formulas go. Main difference is the rectangle has perpendicular lines. Parallelogram is just regular parallelogram. Is base times height, but anytime you have base and height, they have to be the perpendicular sides. And then from there, we had the area of a triangle, which means if we took a parallelogram and drew a diagonal, we have two triangles, and that's why it's half the base times height. Then we had a special parallelogram, which was a rhombus. Now, if it was diagrammed like a parallelogram, you're fine. But otherwise, it's 1/2 D1, D2, and where D1 and D2 are diagonals. And another quadrilateral was the trapezoid. And that's where you have 1/2 the height, add the bases. Still very similar. All three of these are very similar. Then we had the area of a regular polygon, which is taking the quadrilaterals and now going out 5, 6, 7 sides or more. And that's 1/2 AP, where P is the perimeter of the polygon. And since it's regular, that would be the numbers times the length of the sides. Number of sides times the length. And A is the apothem. And that is the perpendicular from center to the side. From that, we had the area of the circle. We're going to see these again later in the class, so I just want to hit them a little bit now. It's pi r squared. Pi r squared. Again, don't confuse that with the circumference, because circumference is 2 pi r or pi d. 2r is not r squared. And after that, the next section we covered before was that we basically, what shapes do you see, what's being put together or cut out, adding them up. This particular section had to do with sectors, and as I commented, this was the food one. Sector is like a pizza slice. Slice of pizza. Typical pizzas. I'm not saying every one of them, but typically you think of a pizza as a circle, and this would be taking out a slice of it. And the segment would be cutting off the crust, cutting straight across the crust. Not a real good circle today, but this would be a sector. Now if I took that sector, which looks like that, and cut it off, this would be the segment. Well, since the sector is part of a circle, but now we're dealing with area, it's not just the arc itself, we're dealing with the area. The area of a sector ends up algebraically converting from take the part, which is this angle in here, over the 360, and I got to consider the area of the circle. There's the pi r squared. So this is the part of the circle, and this is the whole circle. Now, once you have the area of a sector, you can get the area of a segment. That is the area of the sector. Because remember I just said you're cutting off right here, leaving, so you're cutting off or taking away the area of the triangle. So those are the primary formulas that we've had to date. And the only other one they mentioned was that if you have probability, it's just the percent of the area of the desired items versus the area of the entire shape. So then it's just a computation at that point. Majority of these, you had to find the area first. Once you found all the areas, which was doing all this beginning part, then you just go back and fill in for that percentage. And I don't have a preference if it's a decimal or a percent, as long as you do it correctly. And in fact, you could still leave it as a fraction in some cases, because a proportion is really a ratio, or probability is really a ratio. Okay, so that's kind of the condensed version of everything we've had. One round of review. This is your day-to-day to ask questions. Because again, the test is this weekend. So get your questions, but this is one condensed area. Pretty much everything's at. And then I'm going to be using this throughout the whole class period today. Okay? But memorize these formulas. It's not going to do you any good on the test if you don't have them memorized. Okay, on this one, first one, you want to find the area of the blue region. So there's like a part A and a part B. There's two questions here, A and B. Find the area, which I told you need to do anyway, and then find the probability. And in case, with this one it's kind of hard to tell, but if you had your book, this was the blue area that they're talking about. So they told you this amount in here. This is what you're trying to find the area of. So two things I've got to find. The area of the sector, the area of the whole circle. And that tells me this is the diameter, which means since I know the area of a circle is pi r squared, I need r, so that is 5. So now I'm just going to fill in. There's the area of the sector, just using that formula I mentioned earlier. This is the theta. This is the r squared. Everything else was those numbers. Now, in order to find the probability, I need the area of the whole circle, which was this part right in here, and do the percent. Again, with the percents or the decimals, I'll give you a little bit of leeway on this last one. Give you a couple of, if you want to round up, or some of the times the book left it as just 2. Some of the times they went to 3. Just to plan it safe, I went ahead and stayed with the 3. 1 decimal point when I change it to a percent. Okay, questions on this one? Biggest thing, know the formulas, have a good calculator where you know how to use it. Done, crank through. Now number 6, anytime they mention the word chance, you're really looking for probability. So that's just kind of giving you a hint. They're just saying, instead of saying what is the probability. But this one was kind of fun. You had all these X's and boxes that if you stared at very long, you probably started seeing spots and different things. The hard part on this kind of drawing is counting. And I know that sounds silly, but that is the hard part. You've got to be able to count the number of squares because they've already got it in square units, squares. They divided it off for you just like a graph paper was divided off for you. So the hard part is counting. So if I count across this way, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know this is 10 squares this way. And counting down to 3, 4, 5, 6, 7, 8, 9, 10 this way. So I know that's a 10 units by 10 units. So I've got the entire shape is going to be 10 times 10, which is 100. Now I've got to count all those shaded ones. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and keep on, etc. Don't want to feel like it's a first grade class or a kindergarten class where we're counting, but that is the hard part, making sure you count, but don't recount anybody. And when you do that, you find that there are 60 squares shaded. We know that we had a total squares of 100, and doing that ones we wanted was shaded over the entire gives me that amount. I know I kept it very simple, but simple sometimes gets to be the hard ones because those are the ones students tend to miss. So that was number 6. Hard part, count. Especially the shaded ones. You might be able to figure out, you can figure out real quick the entire area, but getting the shaded ones, those were a little harder. Same idea, probability. Another one of those, shaded. Again, do a quick count. I see it's a 10, 10. So that takes care of that one. I know how much it is for the entire. Again, start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, and keep counting. And you find that there are 50 squares shaded, doing the same thing. So key thing on probability, it's the area you wanted, which in this case was just shaded, versus what was in the entire area, every block shaded and unshaded, which made a grand total of 100. And then figure out that percent. make sure you either put a question mark or something to let me know to answer a question if you have something that's bothering you on a particular problem after I've gone over it. This is your day to be ready for get ready for the test. Now, again, this was very much like the early one. A, find the area. B, find the probability. They gave you this. This is one of those games that you had to spin the spinner. So if the diameter is 15, that tells me the radius is 7.5. So I'm going to know I'm going to need that all the way through because the radius is being 7.5, and that's for everyone in this section. Radius being 7.5, that's how I get my area of a circle, which is pi r squared. And then as well as the area of the sector, which is a portion of that. So I want the blue one. And they told me this angle was 72. So there's the area of the blue. Again, this is the angle that I refer to. This is your R. Do the entire circle, and then do the division out. Okay, next one, same idea. Same information, but this time they have purple. Purple, 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 three same size sectors. So I can calculate 1 multiplied by 3. So that's all I'm doing. Taking one of them, multiplying by 3. Now, again, since I know the 3, I know the entire circle, which was the same thing from the previous question. There's my percentage. Now 14, they said you wanted the green. And in this one, this is this one, and this one. But they're not the same size. Not the same. So you got to do each one individually. So I just call this 1, 2, and 3, went from smallest to largest. Do each one of those calculations, add them up, because it still makes all the green pieces. And that's why I just call them green 1, 2, and 3. And the more work you have done on homework, you can go back and backtrack as to why an answer is not right. You can check that. Again, now that I have that, I can add them up. Gives me that amount for just the green. And once I do that, just like before, put over the entire circle, get a percent. Okay. Any questions with the spinner type questions? Any questions on the spinners? This next one is probably one you think of a lot more with this. What's the probability? In this case, skydiver must land on a target with 3 concentric circles. The diameter of the center circle is 2 yards. The circles are spaced 1 yard apart. Find the probability she will land on the shaded area. So it looks something like this. Well, again, this is a radius of 1 yard. If I do it to here, it's 2 yards. If I go all the way out to here, it's 3 yards. So I can get, there's 3 circles there. I have the big one, take away this one, add back in the middle one. So I've got the large, cut out the middle, and add back in the inner, the small one. So that's going to be how I'm going to find the area of the shaded area. And there's my radii for each of the respective circles. So there's the outer, the middle, and the inner one. So just doing that. Now, again, have the outer, take out the middle, add it back in the inner. Because once if I only cut out this part, I don't have an inner circle. So I'd either have one big circle or the thing with adding these at the very beginning, are you, assume the other one. The other question, you could have added those degrees up at the very beginning also. It's always nice to kind of see the parts, but yes, you could have added them up. This one, you would have had to do some of the areas and subtracting and putting back in. That was a little different. But going back, I had that question on this one. Could have added up and did 55 plus 58 plus 60 gives you 173. Then plugged in 173 times pi times 7.5 squared over 360. And that would give you approximately that amount. Now there may be round off error, but it should have been about the same. Okay? Now again, I will give some round off error because I know that will happen, especially depending on what you use for pi. When you punched in the button for pi, that could all make a difference of a little bit right there. So that's why I have some of that round off. I know that part. So again, here's my circles. Getting back to that one. Here's my area for the shaded itself. This one's a little harder. You can't add radius and divide and subtract off radii and do all that kind of thing. So you have to do this in pieces, just like 11.4 where we did the add up and take away parts. This is not a sector. Now that I have that, I have the probability. Well, that means I need the entire circle, which is the big one really, is the entire divided by the shaded divided by the big one. So this particular skydiver would have about a 66.4% chance of hitting the target. roughly 2/3, probably 2 out of 3 chances that person would hit a shaded area. I know ideally they'd rather want to hit in the middle, but to hit a shaded area, that gives them a couple of ranges. So it's about 66.4. Kind of in reference to a question I had a minute ago about could I do a little different. This one I could do a little different, not in the same way, but if I just dealt with the exact values. If I did that, doing the shaded makes arithmetic a lot easier, equals the outer minus the inner or middle plus the inside one. 5 plus 1 is 6 pi. A little easier to add, not have to use the calculator, not think much. And I already know my outer, so I could have said the probability is 6 pi over 9 pi. Pi's are going to cancel out because they're the same numbers, like x. And reduced by 3, you get 2/3. But that would get, punch that in a calculator, you get 0.66 repeating, which is 66.6%. This is why I said you have some round-off error. Because of dealing with the actual pi and using the numbers and at some point rounding it, because you can't really write down every number that you would have, you're going to get some round-off error. So, but both of those would have been correct, and I would have considered both of those as being correct for that reason. So sometimes it's nice if you just can do the easy way. If you got all, you'd see that you're only adding circles, you're dividing by circles, and everything's all the same circles, leave it as pi. The arithmetic becomes a lot easier. Okay? Anybody else? Because probably the hardest problem on here is the next one. And it's not that hard, but it's just the hardest one. Again, area that's shaded, find the probability it's in the section chosen is in that random. There's randomly chosen is in that shaded region. Assume all the inscribed polygons are regular. So that makes it a little nice. We've got regular shapes. If I'm doing regulars, that's the 11-3 section. So that kind of gives you a hint that I'm using that and not having to worry about, okay, how's this formula, which one am I using? So we have that. So we've got an equilateral triangle put in a circle, and I only want what's cut off from here. So that is a segment. But if you notice, if I did just this amount, that is this whole thing is a sector. So a couple of things I got to find out, and I know I'm going to need, so I'm just writing down. I know I'll need the area of the circle. And by the way, this is the diameter again, so the radius is 8. So that gave me that amount because I know I'm going to need it when I do my percents. So I might as well get it done. Area of the sector, I still needed part of that. But this time it's equilateral. Central angle and regular polygon is 360 divided by, in this case, 3. So that gives me the 120. But I got to get the area of the triangle, and this is what I was referring to on this part, my note. So if I look at that area of the triangle, there's the one I've cut off. There's that triangle of the sector. This is 8. This is 8. This I kind of don't know, but I'm going to need it. I can find out my apothem, because the area then deals with the apothem. This is, once I had this is 120, this is 60, this is 30. And as a review, a 30, 60, 90 triangle. This is x, this is 2x, this is x square roots of 3. So if I'm looking at this, 8 is my radius. Cut it down, so the apothem is 4. And this would be 4 square roots of 3. But I cut it in half, so I got 4 on each side, so that means I have a grand total of 8 square roots of 3. So my height is my apothem, and that's the reason for the 4. The 8 square roots of 3 is this. I'll give you a minute to look at that. Again, it's a 30, 60, 90 triangle, and I would definitely know that triangle. We've had that in the past. So there's a 30, 60, 90. So I got the triangle. I have my sector. I can get the segment, as I mentioned at the beginning, is the area of the sector minus the area of the triangle. So filling in those numbers, I get that. Now that I have this, that segment is the one shape I wanted, and I only wanted one of the shaded. I have my entire right in here. I have my probability. And again, depending on where you rounded or when you rounded, that could go up to 20%. So 19.5. Any questions on the last section of the chapter? Any questions? So the next few problems are basically review. A couple of things I want to keep in mind besides formulas. Well, key thing, memorize them. Know them. And I'm going to be hitting through most of them. I hit them earlier, but I will hit them again going through this section. But need to make sure you've had them memorized. Other formulas, these are previous material. That would be handy. Previous, need to know. And this is a good little mini review of part of getting ready for the semester exam in May, but I know that's almost 2 months off, a little less than 2 months now. One, I've just mentioned it. It's a 30, 60, 90 triangle. If this is x, 2x, and it's x is always across from the 30, and this is x square roots of 3. This is it's always in reference to, it's across from the 30, the 2x is across from the right angle, it's the hypotenuse, and the side across from the 60 is the x square roots of 3. And while I'm at it, I'll go ahead and give you the 45, because sometimes that one shows up more in, here's a parallelogram, but I'm only giving you what kind of angles you have. But it still shows up. In that case, you got x, because it's 45, 45, 90. Both sides are the same. This is x square roots of 2. Now, another one, because in the homework we've had was determine what kind of shape do you have, and you needed to know the slope formula. because that would start telling you some things about what kind of shape. So the slope formula itself is subtract the y coordinates over the x coordinates, subtract the x coordinates. I don't care which one is first, as long as it stays first in both of them. It's your choice. But now once you have the slopes, if the slope of one is equal to the slope of the second one, lines are parallel. You have parallel lines. If the slopes equals the negative reciprocal of the other one, which means basically you flipped it and multiplied it by a negative, or if you multiply the two slopes together, you get -1. The lines are perpendicular. So that starts telling you whether you have parallelograms and at least a rectangle. Now after that, and various other cases, but there are times you need to know the lengths, but you're given the vertices again. You need to know how long it is. That's the distance formula. And this came all the way back from chapter 1. We're still using it. And that gives you the length. And in that case, that would help you determine, is it a rectangle? If it's not, or excuse me, is it a square? It does help in other ways, but that's probably one of the key ways that you would end up using it. And after that is pretty much all the same formulas we've been hitting regularly. Now we'll go through those again. Okay, so those are some of the previously things you need to know from previous chapters. I would say these are the key facts to review. This is also a good little review again for getting ready for the exams. So the more you have down and you can pull without having to think a whole lot about it, the easier everything becomes. Now this one, they had some pictures. That's why I said the first 6. Here again is the formulas. First one, it's a triangle. And again, area of a triangle was answer C in their case, but that's equal to half times the base times height. Area of a triangle, base times height. Anytime again I mention base and height, they have to be the sides that are perpendicular to each other. Base times height. Number 2 is a parallelogram. It's base times height again, but it's not half. It's the whole one. It's not a triangle's half the base times height. Parallelogram is base times height. And this also includes a rectangle, where the base and height are the perpendicular sides. So that gives you a little bit of a reminder there. So that also, again, goes for parallelogram, the generic case. And the other one, well, I'll come back to it in a minute, that fits in that category. Number 3, there's your circle. It's pi r squared. Circumference just distance around is 2 pi r or pi d. D does not equal r squared, so that's why these are totally different. One is area, one is circumference. Number 4 is a trapezoid. And when they're referring to height, they're referring to this one, B1, B2, just as long as one's atop the parallel sides. Number 5, this is a sector. And they said that. I don't care here if it's a capital N or theta. That's the theta or N. To me, they're the same thing. N is just the number, that's the number of degrees. It's the same thing. That is the sector. And the last one, they were saying a hexagon, but we didn't have one specifically for a hexagon, but this is in reference to any regular polygon. And that's 1/2 PA, AP, I always did. P is the perimeter. So if this is a side, you would say it is the N times the number of sides. And the apothem is perpendicular to a side from the center. And this would be the apothem right there. Now kind of going back into some other little categories there. Triangle, it doesn't matter what kind of triangle it is, as long as you know where it's perpendicular, where the perpendiculars are. It could be a right triangle, an acute triangle, or an obtuse triangle. Those are all the same. Number 2, the parallelogram. If it's a rectangle, it's the same. If it's a rhombus that looks like this, it could be the rhombus. If it looks like this kind of diagram where they given a base and a height, this is how you would do it. Forget about the sides. But otherwise, if it's rhombus given diagonals, it's 1/2 the D1, D2. It would be something like this. D1 and D2, and it's the entire length. It's half only multiplied once. That takes care of finding the area of the 4 triangles in the middle. And I mentioned on the circle the circumference. And on the sector, this would be in a sector. If I have a segment, this part, that's the area of the sector minus the area of the triangle that you cut off. After that, we're just adding on, putting on pieces. What do you have? That's the bulk of the formulas. And again, those are the same ones I pretty much went through at the beginning of class. Okay. This one, find the perimeter and area of the parallelogram. Again, perimeter, add up the sides. And opposite sides are congruent. So you can double. So if I have this one, I have 36, 36, 22, because it's a parallelogram. So I can just add those, double them up. The 36 and 22 gives you 116 millimeters. Now, again, they didn't give you the height. They gave you the number of degrees here. So if this is x, this is the hypotenuse, that makes that height has to be 11. Going back to that 30, 60, 90 triangle that I mentioned. So I know the hypotenuse is 22. X is going to, that's 2 times x, so that has to be 11. Really don't need the other side anyway. So once I have that, I've got my height. This is my base. There's my height. There's my, fill in the numbers. Again, if you're going to write unit squared, that is the only thing squared. Do not put not 396 squared. Because if I say 396 squared, that gets to be a huge number. Because that means I'm supposed to square that number too. So if you're going to use the units, say what the units are. Those are the items that you're talking about square units. Or the word units if you don't know what the units are. But don't give me just, well, I don't know what the units are, so I'm just going to square the number. A word has to be there to tell me that you have something there to be squared. Otherwise, it's showing me that it's 396 squared, which is a huge number. Okay, number 10 was one of those I was referring to at the beginning. You got your vertices. It's quadrilateral because you got 4 vertices. You want to determine if it's a square, rectangle, or parallelogram. First of all, find out if it's parallelogram first. Because if it's not, the other 2 are not going to work anyway. Then determine from that if it's a rectangle. If it's a rectangle, okay, you can go on a little farther. If it's not a rectangle, you can't go any farther. So that's how you would end up, even though they're writing it as square, rectangles, parallelogram, I would start with the parallelogram first. And again, use slopes. The easiest way. Your pictures will help, but they won't guarantee. They will give you a hint, but they don't always guarantee. So sometimes, because the only way you can be guaranteed is if you have definite lines that are following the vertical and horizontal lines on graph paper. If you don't, you're not guaranteed it. So if I have these, I go through my slopes. There's my slope. And I see that I have these 2 are the same. These 2 are the same. So that tells me EF is parallel to GH. And FG is parallel to EH. 2 sides are parallel. That means I have a parallelogram. So at least I have that. Now, if I look at consecutive sides, these are every other one because I want opposite sides being parallel. Consecutive sides, if I go 0 times 4, that equals 0. It's not equal to -1. And I can't say that 0 equals a negative of 1 over 4. Those are not the same either. However you want to look at it. So they're not perpendicular. So I don't have right angles. So I don't have a rectangle. And if I don't have a rectangle, there's no way I can have a square. So parallelogram is the only one I can have. Now I got to find the area. That was part B. A, B. 2 parts. Find the area. I need a base. Well, if I look at this one, these are on the same Y line, so this would kind of be my base. I'm just going to start there because I know one of them's got to be. If I look at that, I've got my base. The difference from 7 to 1 is 6 steps. So it takes care of that. Now, if I know that's my base, I've got it, and they're both the same number. It makes it kind of nice because I know they're horizontal. If I want to look at my vertical lines, how far is it from here to here. That's going to tell me the one next to it. Basically, all I'm looking at is my y's, how far from the top line to the bottom line. And that gives me from -2 to 2 is a unit of 4. Again, or if I'm looking at straight on the graph paper, it's exactly how many steps straight do I have to go. Now I have my area, base times height. Okay, 12, same idea. Go get this first, second, then third. And then after I do all that, I'll get the area. So I have these. Well, the other one I could see, okay, there's a horizontal and vertical lines because I had the same things. If I was to sketch this, I would start noticing real quick, and I'm going to do it as a quick sketch. -7, -1, be something like here. -3, 3. -1, 1. -5, -3. So it's kind of like this. So your eyes kind of give you a deceiving look. It's like, what is it? But probably, okay, I can see it's probably a parallelogram, but that's all my eyes can tell me. So again, do the slopes. So I do my slopes. That tells me PQ is parallel to RS because they are the same, and QR is parallel to PS because they are the same. And remember I said negative reciprocals. If I multiply the two next ones together, 1 times -1 is -1, or 1 equals the negative of 1 over -1, which two negatives make a positive. So this tells me PQ is perpendicular to QR, and QR is perpendicular to RS. And I can go around that way and say, okay, they're all perpendicular. So I know I have a parallelogram. I know I have a rectangle. Now I got to check to see if I have a square. Again, I'm going to check my distances. My PQ and QR. It's consecutive sides have to be the same. So I've got to prove that or know that. And also, since I know that there are consecutive sides, that also gives me my base and height. So no matter what, those consecutive sides, since it's a right angle, are base and height. So I kind of need them anyway. So there's my base and height. These are not the same. So they're not. So if two sides are not the same, that means I don't have a square because they have to all be the same. So I don't have a square. But this is where you check. If they were the same there, they would go, and you already know that they're parallel and they're perpendicular. You only need to check 2 of them because opposite sides have to be the same. Now I've got PQ is my base, QR is my height. I have my numbers and filling in for the area. Base times height. Quick review. Square root times a square root. If you're multiplying a square root times a square root, insides multiplied together, outside numbers together. They don't crisscross those borders. So that's what I ended up doing. 32 times 8 is 256. Now I can check and see, is it simple? And if I take the square root of 256, I'm going to get 16. And typically in Algebra 1 or at least in Algebra 2, you might, if it didn't go in simply, then you may want to learn how to reduce those or simplify them where you can bring out similar units. But right now, that's how I would keep it. So you get your area. It was a rectangle, and the area was 16. And you notice I used the word units. They didn't tell me, other than I knew there were little squares, how much a square is worth. Okay? You want to find the missing sides or missing measure. In this case, given a trapezoid, has the area, find the height. Well, I know what the formula of a trapezoid is. Area equals half height base 1 base 2. I know this. I know these two because of the drawing. So I'm going to do some of the algebra, filling in, solving for h. Now, if you remember, I said especially if this was an odd number, if I didn't want to deal with fractions, I could have gone this line and multiplied both sides by 2. So I don't have to deal with fractions. 150 equals h times 13 plus 17. And that gives me 30 still. Divide both sides by 30. I still get 5. So it's your choice. If it's odd, I would probably get rid of the fraction. Even, you don't have to because the 2 goes into an even number. If you just want to always get rid of the fraction, that's fine. Kind of hit some of the algebra stuff. Now, this one, find the area of the polygon, and it was a regular decagon. Well, regular. A equals 1/2 AP. Decagon. Got to know some of those terms we mentioned at the very beginning of the year, especially the prefixes. If you see deca, that means 10. 10 sides. And 10 sides and angles. And each side is 12. So we know a lot from just those few words. I'm going to need to know, this is one we haven't done as many with, but we did quite a few back on that homework on 11.3. And I'm going to kind of draw, this is one of the triangles that would have been drawn off from the central. This is the center. Vertice, vertice. We know this is 12. I don't know what the central angle is. Central angle is 360 divided by the number of sides. So in this case, it's 360 divided by 10 gives me 36. That's 36. I do know this information, so I can get my perimeter because I needed it. So that's done. The reason I need my central angle is to find the apothem. And this is the other one we probably need to remember, especially to find the apothem. In other triangles, the sides 30, 60, 90, or 45, 45, 90. Because those you could sit there and do the basic tricks. I know that. So I've got the apothem. I need that, but my apothem is right here. Cuts everything in half. So that gives me this. This is 18. 36 divided by 2. This is 6. It's a right angle. I need to find the apothem right here. So we're going to end up using tangent of the angle equals the opposite over the adjacent. Don't need to know the other one. In this case, the opposite is, or the theta is about half the central angle. The opposite side is half the side, because we bisected if we know that from the beginning. And the adjacent is the apothem. So I'm going to fill in that. So I know 18, I know this is 6 over A, and I start getting that. This is the calculator. I would leave tangent of 18 in and just let the calculator do it at the end. But if you want to keep track of the numbers, you're welcome to do that. It could cause some round-off error. So that gives me the apothem. The second thing I need. Now I've got the formula, 1/2 AP. Depending on this, your answer could vary from here. For example, punching in exactly as it is right now, you would get about a 1,110. If you left tangent of theta and plugged in, say, this whole amount right here, and let the calculator do it all at one time, you would get the 11.0, or 1,108. So it's, watch your calculator. There is going to be round off, depending on what you use for these numbers. So I realize that, but you need to get as close as possible. So that's the key thing. Watch the calculator. If you want to just leave it all in here and punch in the calculator, 1/2 times 6 divided by tangent over 18. Typically, you have to make sure that parentheses is finished on the calculator, times 120. That's going to give you this answer. If you rounded it at any point along the way before you started punching it all in, it's going to vary. So there is some leeway. So if you got a slightly different answer, if it's relatively close, then it's fine. Okay? And this one, find the area to the nearest tenth. This is, what do you see? Well, I see a semicircle. Semicircle is half of a circle, which I know an area then would be half of pi r squared, because there's the circle. Has a radius of 4. There's my radius. And the other one, but the only thing I can guess, this is a trapezoid. But I don't know I have the height. But again, I have that 30, 60, 90 triangle. So if this is 4 from here to here, from here to here, which is my hypotenuse, is 8. Across from this is going to be 4. But I need the side over here. This is my height. And so I had to find this side. Now this is x square roots of 3. So my height is x is 4 square roots of 3. So I have my basis, have my height. So now let's go through those formulas. Semicircle, half. Trapezoid, get my height, fill in the blanks, let the calculator do the work since you're saying rounding. Now as I look at it, I see I have a trapezoid and I've got a semicircle added to it. So I'm adding those pieces together. There's my answer. Okay, questions on that one? That's why I said you really need to know the 30, 60, 90. Kind of shows up either directly or indirectly. Sometimes indirectly, like that circle we had with the segment that we had to find. Or directly, like in this, where it actually pointed out, you've got a 60-degree angle. Hint, hint. Now the last one. This was like the last ones we went over today. Basically find the probability. You didn't have to find the area of the sector, but you're going to need it anyway. You need purple or green. So the purple one, it's kind of hard just with the shading, is here. The green is here. So again, I've got to add those two together. I got this section and this section. So in my whole circle, I know I'm going to need that for the probability. So that gives me the area of the purple, area of the green. I'm just doing this. Add them up. Since I have it on pi and left the pi in there, without punching the calculator, I could do it this way. If I punch it in the calculator, you're going to get comparable numbers, pretty close. Which would be about 30.16. Just give a little bit more accuracy. Now I need the probability. Again, taking the top divided by the bottom gives me that. Now if I did these numbers, did the probability, I get 0.266 repeating, which is effectively that. So that one came up pretty close because of the repeating. So you can still get the same answer. Just keep in mind how far you go out with pi. But if you do this, you don't have to worry about pi because they cancel out. You just do a quick divide. Okay. Any questions on anything for the test? Anybody have any questions they wrote down they needed to make sure they knew or understood, problem or whatever? Anybody? Anyone? Questions? Okay. Again, if you're studying, make sure you've gone through all those formulas. Even the ones I said were previously needed, you will probably need them. And if you can get it to me by Sunday evening. If there's a problem, let me know as soon as possible getting to me because I definitely would like to have them before, at least in my hands and on my computer by the time your class starts next week, first class. May not get it back to you that quick, but at least I could do that part. I did mail them out yesterday evening. So the test your parents should have. If they don't have them, send me that email. Have them email me and say, I didn't, you might ask them just to make sure. I did check, but sometimes email is kind of crazy. Who knows? If you have questions, you're welcome to stay on these last few minutes. And I can stay here. If you don't have questions, you're welcome to go and study or eat lunch early with Tanner.